forward face of Google's products, APIs, and services, and we work with partners of all different sizes and help them get online smoothly, productively with our products and APIs. So as part of Chrome, we work with partners who are building things for the open web platform with HTML5, soon native client, launching those apps and games on Chrome Web Store. We have Chrome Frame, obviously as a plugin for legacy browsers to bring along all that great HTML5 technologies. Chrome Enterprise and Chrome OS and Chromebooks. So a lot going on in the Chrome world. I like to focus on games. Games is really obviously a lot of fun, and it also pushes the platform. It really exposes the areas that we need to accelerate or optimize. It also shows us where we can go with new areas and new features of the platform. And obviously games are very important for any marketplace or any distribution channel. I think something like 60% of the popular apps in the App Store are games, for instance. It drives a ton of revenue. So it's important for both our publishers and Chrome and Google. So games is really critical. I love it. We're working on it. We're working hard on it. And so I would like to introduce a speaker for this tech talk, Rob Hawks. Rob Hawks will be talking about HTML5 multiplayer games with us today. So he's an author of Foundation Canvas, a new book on Canvas, which is one of HTML5's new APIs, allows you to basically have a bitmap 2D drawing context in HTML5, so very important and relevant to games. He's also technical evangelist at Mozilla, just recently started there. And he's also very passionate about games. And so he started early building multiplayer HTML5 games, has learned a lot of great lessons along the way. So I'd like to introduce Rob to tell us all about multiplayer HTML5 games.
Thank you. Cool. Is this working? Is that on? Cool. Yeah, so I'm Rob. So I'm here today to talk to you about Rawkets, which is a multiplayer HTML5 game that I created really sort of recently while I was at university. Which I just finished. So yeah, it's a multiplayer space shooter. It's quite fun. It was an experiment into sort of gaming and learning about WebSockets and stuff like that. So sort of throughout this talk, I sort of plan to go through that, some of the theories, some code behind it. Not too much code, more just the theory and sort of the interesting things, the lessons that I learned throughout the journey. Yeah, so it's definitely a light-hearted talk, so feel free to stop me like at any point if you have a question. It's not too formal. I'm quite happy to stop, and if you just raise your hand, that's no problem. We'll just sort of go from there. So yeah, so I work for Mozilla, as Seth said. I'm a technical evangelist there. I've been there for about just over a month. Sort of came out of university and went straight there, which was interesting. So yeah, it's my job to engage with developers about new web technologies like HTML5 and related stuff like JavaScript. So just as a sort of clarification, when I refer to HTML5, I'm talking about HTML5 and JavaScript. It's too much effort to say the two things all the time. So yeah, so aside from my work at Mozilla, I'm obviously sort of addicted to HTML5 and visual programming. So you'll probably recognize the HTML5 logo. Some nice guy sort of created a custom version of it for me, which had sort of NASA background with my own rocket on the back, flying around it, which was interesting. So I might get that on a t-shirt or something, I don't know. But yeah, so I'm addicted to this technology. I think it's fun. I like experimenting with it. It's easy to use. It's quite cool. It's still sort of being developed at the moment. And just that constant changing and just the ease of use, it's just really, really interesting to me. And this experimentation has sort of led to me looking at sort of multiplayer games and gaming in particular on HTML5. And Rawkets is sort of a graduate from my experimentation. And like I said, I studied at university from a desire to learn WebSockets. So the game now is much more mature. Like I said, it's graduated from sort of my lab, I suppose. And I'd consider it a separate entity. I'm sort of using it now to sort of push other new web technologies into it, to use it as a base to sort of try out new features. I think gaming's a kind of process that you can apply so many different sort of practices to. It's a really good way of testing out lots of features all at once. So I mean, that was sort of my process behind creating it. So I don't know if, has anyone seen Rawkets yet? A few people, that's not too bad. So Rawkets is basically short for Rawks, WebSockets, and Rockets. Rawks is my personal blog. It's sort of short for my full name. And the name's besides the point, really. The game is as you can see here, is a massive, well, not massively yet, it's a multiplayer space shooter. You have to apologise for the lag in this video. You basically fly around and you've got little sort of ring of health around you. If you fire, your ring goes down. If you get hit, your ring also goes down. So be very careful about how much you fire, because if you fire too much, someone can sort of knock you off in one shot. Yeah, I was sort of keep playing. But yeah, so it's just an interesting, quite a simple game in terms of graphics and stuff. I was more interested in playing around with multiplayer communication with WebSockets and stuff. So it's the theory behind it that I was quite interested in. It's not even at a beta release yet, and we'll get into why in a moment. So you've probably realized that the graphics that I showed you at the beginning aren't the graphics in the game. I'm sorry about that. I don't think Canvas or WebGL are quite there yet. Maybe soon, I don't know. So we'll see. But yeah, that graphic is something I got commissioned for the game actually by an artist called Reed7, and I think it's pretty cool. So yeah, I mean, maybe one day, we'll see. So I mean, yeah, I mean, that's a 6-foot version of the banner. That was me at my university grad show. And I mean, if you don't think that's that big, consider it's like 8 feet behind me. It's pretty big. But yeah, it's pretty cool. My girlfriend actually wanted me to put it up in the flat for some reason, so I had to actually say no because it smells of ink. So, but anyway. So yeah, I mean the technologies behind.
By the way, thanks for your help. But if I need to end this, I can still end the meeting, right?
Sorry,
So,
just end from the remote.
Okay.
Sorry,
if the room, if it goes longer, I can still end the meeting. Okay.
Hello,
right,
can you please mute your mic? People on the VC.
Right.
Please mute. Thank you.
Sorry, I got confused what was going on there. I thought he was asking me a question. So yeah, technologies. So the technologies behind Rawkets, there's quite a few of them. So you've got your simple ones like your HTML and JavaScript. That's just a given, really. So all of the other technologies are tightly related to that in some way. So for example, you've got Canvas. So that's doing the 2D rendering of most of the game graphics, apart from the sort of the UI, which is CSS and HTML. So the Canvas, like Seth was saying earlier, is a 2D bitmap platform. So how many people have played with Canvas so far? It's a fair chunk of you. So yeah, it's a good technology to play with. It's really simple to use. It's getting better with things like hardware acceleration and stuff like that. It's not perfect, but it was something I wanted to play with because it was really easy to use and it was new and it was exciting. The one thing in the game that isn't HTML or HTML5 even is I've got some flash audio, and I'll explain why I've got that in there later on. There's basically a few sort of problems with the HTML5 version. So yeah, I mean the audio is just playing with the background sounds and the sound effects, but you could use HTML5 audio for this kind of stuff. And there's also WebSockets. Has anyone played with WebSockets yet? A couple of you. So yeah, and this is a really interesting one. I mean, this is why I created the game, and it's the concept of communicating between a client and the server in real time. I think is quite an interesting one. Not just in gaming. It's basically just an upgraded sort of HTTP connection. It's like bi-directional real-time communication and stuff. It's pretty cool. So I'd definitely look into that. And then that's all on the client side. On the server side, I've got Node.js running. So it's JavaScript on the server. It's a pretty cool language. I mean, is anyone who's played with that one? That's cool. Yeah, it's a good language. I just found it really easy to sort of use because it's the same language I'm writing the game in on the client side. At the moment, I just use Node for game logic and the WebSockets communication. Eventually, I'll be using it for like authentication of players, so you can have like they can log into the game and using some sort of storage mechanism, maybe Redis or MongoDB, to add a layer of persistence so they can play the game, rack up some kills, get some achievements, and log off. Come back on 2 days later, and they'll still have all their statistics. Because right now there's nothing there. It's if you refresh the game, you lose everything that you had before. So it's something I'm definitely looking into. And like I said, there's reasons why this isn't even at a beta stage yet. So throughout the development, there's been quite a few issues. I was fairly new to game development, multiplayer game development in particular, when I started this game sort of early on last year. Yeah, I mean, we'll go through the main challenges that I sort of hit, but you'll hit them pretty quick, especially in multiplayer gaming, and it's important to sort of be aware of them and the kind of solutions that you can sort of approach to get around them. So I'll cover a few of those now. So just bear with me. So the main one that I've had a problem with is networking with the WebSockets, but just the concepts involved in networking in particular. Yeah, this probably stems from my inexperience with sort of socket communications and all of that kind of stuff. I never really dabbled in that in desktop programming, and I hadn't done multiplayer gaming in particular before. So a lot of these issues, they're probably fairly standard networking problems. But if you're a web developer just looking to get into gaming, or you're, I don't know, you've done single player games and you want to do multiplayer, they're going to be things that you get a bit weirded out by. The original version of the game, the prototype even, the networking was woefully simple, and everything was transmitted sort of raw in verbose text format, and it was just wrong, really, really wrong. And in hindsight now, it's obvious why. I was experiencing massive performance decreases and stuff. It was just simple little things, and we'll go through a couple of them soon. But I was basically, the crux of it was I was basically sending too much data, way too much data back and forth. So there was a couple of ways to go around that, and one of these was just coming up with a simple sort of message protocol. So the way I did this was to sort of come up with a way of structuring the messages that were being sent back and forth. So this included assigning each message a type, and the way I did that was with enumeration. So I was assigning it sort of, it was a number, the type, so it was quite short and it was easy to remember, but I was using sort of a structure like that in JavaScript just to, so in the code I could use the word representation of the message type, so it made sense when you were reading through the code. But when I was sending the message through the WebSocket, I just had to use the number. So it was nice and short. I didn't really care what was going through the socket, as long as on the other end you have the same types, you can translate it back. This was just a really simple thing to implement, and it cut down length of messages going through WebSockets, because WebSockets only uses text at the moment to transmit. There's no other way of doing it. So if you can cut down the length of your messages even by 1 character, you're really going to sort of help yourself out. So doing something like this, you can cut it down by really a lot. And then sort of coupled this with a sort of an overall message package. So I was using JSON to do this. So you'd store it as a JavaScript object on the server or the client, whatever. And then when you came to send it, you would sort of pass it through JSON, or even Bison, which I'll get onto in a second. But all the other pieces of data were attached to this JSON object. So the Z that you see up there is the message type. The reason why it's called Z, there is no reason. It just was. It was a letter that I didn't think I was going to use. You could use anything. The rest of them, this is just an example message of a player update. So the ID is the player ID. S is the state of the player, which is another object which has just got the X, the Y, the velocity, and the angle. And you could probably cut this down even further. You might not want to use JSON at all. You could just sort of use a really, really short string with some separators or whatever, or not even separators if you know how long each section is going to be. But what I'm saying is you just need to be aware that compressing the data is really important. And I wasn't aware of this at the beginning, and it really bit me, because when you get more than 10 players in your game and you've got them all firing, say, 20 bullets each, you've got a lot of data flying back and forth. So yeah, so the compression side of things is quite interesting. So just cut the stuff down, reduce the length of words, really simple stuff. But like I said, there was something called Bison, which I was looking at, which is a binary representation of JSON. I don't know too much about it myself. All I know is that in some cases it can cut, say, certain characters down by 4 sorry, not certain characters. You can say you've got a string, you can cut the amount of characters within it down enough to make it worthwhile to use. But it's worth looking into. All of the slides and the notes and the links and stuff I'll be putting up online afterwards, and there'll be sort of links to my website at the end. So don't worry too much about taking notes. So yeah, aside from this sort of compression side of stuff, there was the rate limiting. And this is probably the biggest issue I had with the networking. And it was just, like I said at the beginning, the sheer amount of data that you're sending back and forth just bit me straight away. And I took me a little while to work out what was going on, but it was fairly obvious when someone pointed it out that you're just sending way too much data. And it's not just because of the length of the strings and stuff. It's about how many players you've got in the game and the way your game is sending that data. So having only one player in your game is fairly simple. The way I've set up Rawkets is you send a message to the server then does some logic and sends your position back. So you'll have, if you're one player, one message going in and one message coming out. Pretty straightforward. Two players, you got two messages coming in, one from each player, and then you've got 4 messages coming back out. And this is on the server's perspective. So there'll be 2 updates going to each player. So that's 4. So 2 in, 4 out. So it's not too bad. So if you've got 4 players, 4 messages in, 16 messages out. So you can see now, if you haven't already noticed, it's the messages going out is the square of the messages going in. So if you have 30 players, 30 messages coming in, 900 messages going out. So you can see how quickly this builds up. And this is just, say, for example, if there's 30 players not shooting anything, they're just moving around. So, and this is per frame as well, or per update on the game. So, I mean, say your game's running, I don't know, 60 frames a second, 30 frames a second, you've got 900 messages going out just for movement in that frame. So imagine if they all started shooting, this number's going to shoot up really quickly. But let's go further still. Imagine you've got 100 players in your game. So you're getting sort of massively multiplayer. There's 10,000 messages going out. This is just, you're not going to be able to work this with WebSockets at the moment. So this tripped me up completely. I was aiming to do this massively multiplayer game where you could have thousands of players in the game, and it's just not going to happen because your server's going to die. So there's ways to get around this, and like particularly games like, I think, World of Warcraft or other games, they have the concept of like range and visibility. So if you say can't see a certain distance, you don't really care what's there, so you don't get the updates about what's there. So originally in Rawkets, I was sending updates for everyone that was in the game, regardless of whether you could see them, which was, in hindsight, a stupid thing to do. So you need to make your game intelligent. That was the main lesson I learned, especially on the server side of things, where it doesn't really know what's going on the client side. So you need to tell it things. So you're using HTML and JavaScript. You can tell it the dimensions of the screen. It's really simple. You can tell it all sorts of things. So fortunately, there's a way around this. So you can seriously cut down on the amount of messages by knowing the screen dimensions. So if you know the screen dimensions of each player, you know what players are within that screen dimension, what bullets are within that screen dimension, and only send those updates. And by doing that simple check, in Rawkets, I managed to cut down the amount of messages sent back and forth immensely. It was just incredible. But it's just really simple tricks. So another really, really simple one that you might not think of straight away is only send updates for players that are moving, that have moved since the last frame, because if they're not moving and they're not doing anything, then you don't need to waste bandwidth sending messages about them. It's really, really simple little things like that that make the difference. So another networking thing that I sort of found interesting, and there's a bit of debate about this, is WebSockets is TCP based. There's no UDP support for this yet. A lot of people think that's a reason not to use it. I kind of see that, but I've not had a problem yet. You just need to respect it. You just need to be aware of what TCP means and what kind of issues you're going to get related to that. So it's not a problem, really. you just need to play by the rules. So I should probably point out that I could have used that icon because it's WebSockets and whatever, but it's not. It's a US plug socket. I kind of liked it because it looks like a surprised face, which you don't really get that in the UK. Always makes me laugh. I don't know why. So yeah, so TCP, you just need to be aware of the things involved. Like obeying the order. There's the whole concept of TCP is that the stuff's going to come through in order, and it will wait until packets get dropped. It will try and grab them and put them through back in order. Like I said, I don't know too much about the fundamental networking principles here. I just know what I've learned through my game development experience. And this is one that sort of bit me before, is you've got players running around, and especially if, say, before I did the compression and stuff like that, if someone lags out a little bit and their messages get backed up, you're going to get this guy stuck for a moment, and then suddenly everything will catch up again, and it'll go zipping around the screen as all the messages come in and you update. So you need to be aware that these things are going to happen. And it may sound simple, but it's the kind of stuff that the average sort of web developer or someone who's not done multiplayer gaming before is not really going to think about until it bites them, and then what do they do? So yeah, in short, I mean, the ordering stuff's going to make it a bit jumpy. And with UDP, yeah, this wouldn't be much of a problem. Sorry, go. So yeah, but you're still going to have to wait for the messages to... Sure, yeah. So yeah, you could, there's something that we will look into in a moment, is getting rid of the jumpiness. But yeah, you could effectively ignore the messages up to the most recent point in time, definitely. So yeah, like this man said, there is ways to get around this. You just need to be aware that these problems do exist. And realistically, it's not much of a big deal. I mean, okay, yeah, if you're making Counter-Strike, perhaps, but if you're just working on, say, a 2D space shooter or a platformer, or not even those kinds of games, maybe a massively multiplayer Scrabble game, I don't know, which exists, by the way. Some of these issues, it doesn't matter if there's a little bit of lag, if some things don't come through in order. You just be aware of it. I mean, there's something, sort of a theory that I've sort of heard of. I haven't put this into play yet, and I haven't tackled it head on, but it's sort of the idea of forcing a delay in the game. So what I mean by that is, say, if every player is sort of, I don't know, 50, 100 milliseconds behind what's happening on the server, you sort of have a buffer period to catch up if there's any issues. Now, as for how to implement that, I'm not sort of 100% on it. I've seen a few sort of big game companies talking about this kind of approach in certain ways. So I'll have to look into that more. Maybe I'll put it on my website afterwards. But it's just something to think about, that there's, say, certain ways to get around these kinds of things as long as you're aware of them. And a really simple one, just use Socket.io. This is a Node plugin that gives you WebSockets. So simple to use. The actual website for it is just socket.io. And they've just released a version 0.7 like 2 weeks ago, which is a massive update for them, and it brings some really, really cool stuff. But one of the best things that came in with it is the idea of volatile messages. So the way these work is, if you send a volatile message using Socket.io, which is completely voluntary, you would have to say, I want to send this as a volatile message. If the person you're sending that to is having, say, connection issues, or is busy doing something else, Socket.io will know about this, and it will just drop that message. It won't keep trying to resend it and all of that kind of stuff. So you can... Sorry, there's a question. Socket.io. It's JavaScript. So it's WebSockets, which is JavaScript, yes. So yeah, it's got a Node.js plugin for the server, and a client-side sort of plugin as well, just to do the connection stuff. So it just uses a really simple API. It's a great way to sort of put WebSockets into something really, really easily. So yeah, the volatile messages, you can sort of take away a few of the sort of dodgy TCP stuff that might trip you up, but it's not an ideal situation. It's not an ideal solution, but it's going to help. So it's just nice to be aware of these kinds of things. So another big thing that's bugged me in the game is cheaters, who are both a blessing and a curse. Um, so there's no denying it. You're using open technologies. You're not compiling your code. Your code's open, right? So it's visible to anyone who wants to view the source, and it doesn't matter whether you minify or obfuscate your code. Someone's going to be able to work out what's going on or just play around with something and screw something up. That's just the way it works, right? So I experienced this pretty much straight away when I developed Rawkets. So I probably released it, and then a few hours later, someone had decided to put rapid fire in the game. Wasn't part of the release. So you had 300 bullets a second flying around. Everyone was dying. It wasn't happy. And the server crashed, which was even greater. And I'll actually talk about how I dealt with that afterwards. But straight after that, he was working on invincibility, super speed. Someone else then grabbed his code because he was just sharing it and allowed them to sort of paste it into the web console. And he had his own features in his game. So they were just making new features to my game, and I didn't have to do anything, except it kept crashing because I wasn't expecting it, right? So one guy, I think my favorite one, he managed to create an entire new weapon. He didn't just manipulate the old one. He created a cluster bomb, and I had only put bullets that fired once every 300 milliseconds in. And he managed to completely manipulate everything because of my naivety and fire, say, I don't know, 50 bullets all at once at different angles that just wiped out everyone on the screen, right? So it's pretty cool. And don't get me wrong, this was annoying, but it was awesome to get this free testing that I would never have found any of that. I would probably still be finding it today if I didn't have, say, 20 people all on at once trying to break my game. Not because I asked them to, just because they can see the code and they're thinking, well, screw it, I'm going to break it. And it's good. I think that's something that comes with these technologies, and I think it's something to embrace. That's why I say it's a blessing as well as a curse. As long as you keep up with them, and the other thing with this is using Node with JavaScript on the server and JavaScript on the client. It's so easy just to run into the server, just make a quick change, restart the server, not even the whole server, just Node. And you've got a fix up in, say, a few seconds. You don't have to do any compilation and any of that. And they'd screw up the game, I'd fix it, and they'd be annoyed, but they'd break it again by doing something else. So it's a constant battle, but I think it's a good thing. But the reason why this was all happening was because I was being naive with my JavaScript. I was using the global namespace, and I had no closures in my code, and all of those sort of things that you probably should do, and I wasn't doing. So the cheating was prevalent because it was so easy just to run in, go into the console, have a look at what sort of variables I've set, file into them, and sort of drill down into them, and say, oh, look, there's the speed setting. Let's change that to, say, I don't know, 1 millisecond instead of 300 milliseconds. There we go. I've got rapid fire. It was that easy. So the easy way to fix that was using my own Rawkets namespace and putting some sort of closures in correct areas and private variables, which aren't technically private, but whatever. So just being aware of the security of your app as well. It's not going to be perfect, and it's not going to stop people doing it, but it's going to help at least. The ways to actually prevent cheating completely, I'll get onto after this. So I mean, this was just a simple representation of how I put the Rawkets namespace in. It's just a standard thing. I think that I got this out of a JavaScript patterns book. I can't remember the name of the author, but I'll put the link on the slides afterwards. And just this kind of stuff, just simple stuff, it helps. So the actual way to prevent cheating completely is to not do this, which is what I was doing. So I had an authoritative client, which it sounds like you know is a bad thing, right?
Discovering everything John Carmack figured out about 15 years ago.
No, well, exactly. It's and this is what's happening is like guys that haven't been involved in this multiplayer networking and whatever is with web developers that have started looking into this, and it's another example is with Canvas and stuff, we're learning from Flash guys because they've gone through all this before, right? So it's quite interesting. So yeah, the first version of Rawkets was way too trusting. So it was an authoritative client. It meant that whatever the client did, it trusted and sent it to the server. And the server went, oh, yep, that's where you are right now. Okay, yeah, I'm going to send that to everyone else. And all you need to do is change that position on your client, and it sends that random position to the server, and you've got rapid speed. Or invisibility. You can just kind of flip around all over the place. It was crazy. It's a really bad way of doing things. And for single player, obviously, it's fine, regardless of whether you've got a server doing anything. It's when you're doing multiplayer and it gets quite interesting. So this is referred to as all sorts of things. I call it the here I am approach. I know a few other guys call it that. It's the client just basically keeps going to the server, here I am, here I am, here I am, and the server just goes, okay, and sends it to everyone else. So the right way to do it is using an authoritative server. And basically this means that it prevents manipulation of the client, because whatever happens on the client, the server is the authority. The server is the one that decides where the position is. It knows where all the information about the player. If the player wants to change that, the server has to make sure that's okay and send that position back to the client. The client has to obey the server effectively. So in Rawkets now it's fixed at least, all the movement logic is done on the server. The client goes, you press down your arrow key, the client sends I want to move forward request using the JSON message types and whatever. The server then goes, okay, this guy wants to move forward. He's at this position right now. He's only allowed to move, because of his rocket type, he's only allowed to move, say, 5 pixels forward. It's not as simple as that. It will use physics and whatever, but he'll move him a certain amount forward. Then the server will then send the message back to the client saying, this is your new position, right? So this is a sort of approach called, like, where am I? It's a different one. It's the client's going, where am I now? Where am I now? Where am I now? And there's an issue here. Has anyone spotted the issue? Yeah, the latency. Correct. So the problem is latency, and what's happening is, because it's not, the client is sending the update whenever you press the key press, right? So it's got to take however long it's going to take to get to the server, say 40 milliseconds. The server's then got to do its stuff, which is probably pretty quick anyway. So for the sake of this illustration, it's 0 milliseconds. And then it's got to come back again to the client. So another 40 milliseconds, say. Round trip, 80 milliseconds. So if you press your key down, you've got to wait 80 milliseconds before your position, your new one, comes back. So you've got this jumpiness. Now, it might not be that noticeable, but it kind of is when you're sort of trying to rotate and you're a real-time game when you're trying to shoot people in the face. And yeah, you want it nice and slick. So the way to get around this is client-side prediction. Like this guy was saying, it's sort of interpolation and all sorts of stuff like that. And it's basically saying that server authority isn't enough. It's going to prevent the cheating, but it's going to create a new problem in that you've got jumpy players, and jumpy players is not a fun game. So what I mean by prediction is sort of, you need to put some power back on the client side, whether that's a similar physics engine that you've got on the server. But what I mean by this is, you need to let the client move the player while the message is going off to the server and being corrected and moved and whatever, and you're waiting for that message to come back saying you're here. The client's already made its move and kind of predicted, as it says, where it should go. And this happens straight away. Like I said, it happens as soon as you've made the key press. So you make the key press, the client prediction happens, and it moves you to where it thinks you should go, because you're sending just the input message out to the server. You know that on the client. So if you have the same physics engine, you can, or whatever, you can kind of pretty accurately, as long as they've not done anything dodgy, you can pretty accurately guess where the client's going to go now, or where they should be at least, based on that input. So then what happens is, once the message has come back on the update, you've got to do something, because you can't trust the client. You're going to have the same problem here. If you're doing the server authority and then you're doing the prediction and then you're not doing anything afterwards, you're going to have the same problem where, yeah, okay, everyone else is going to see this correct position for this guy, but if this guy's screwing up his own game, he's going to be seeing something completely different, because he might not be doing this deliberately. He's going to be seeing something completely different. So you've got to do something. So correction, you've got to do some sort of correction, whether that's interpolation or some other kind of interpolation. So whereas the authoritative sort of server would have been in control, you relinquish some of that. You let the client do its stuff. The authoritative server goes, right, this is where you should be right now. And the client then goes, okay, so the server's told me I need to be here. I'm here. Is this right? So, yeah, so the way to do this, I mean, it may sound simple in concept, but I mean, this is one of the hardest things I've dealt with. And I've still not fully cracked it. I've got the concept down. There is a lot of work that's been put into this in traditional like desktop gaming languages and stuff like that. There is barely anybody that's tried to do this well that hasn't been brought up in JavaScript. It's pretty impressive. There is, whether they've done it, that's besides the point. Whether they've shared how they've done it, that's the main thing. So it's something that's really important right now, and it's kind of something I want people to learn about, because it's quite a sticky subject. So I mean, don't worry about what this actually means. I've cut some stuff out, but this is my basic sort of correction sort of function, and this is part of a bigger class that deals with movement history and stuff like that. And I took this approach from a guy called Glenn Fiedler even. I need to really learn how to pronounce his name. Who runs a website called Gaffer on Games, which is a sort of desktop gaming resource. It's fantastic. But the problem is porting all that kind of stuff to JavaScript. Certain bits and bobs aren't going to work exactly the same. So it's a bit of guesswork somewhere. So yeah, so I mean, the basic, what's happening here is you get a correction from the server, which has got a timestamp. So the reason why the timestamp is there, because the client and the server have synced clocks effectively, right when you connect to the game. The way you do that is you sort of calculate the latency averagely. You're not going to get it super perfect, but it'll be near enough. You sync your clocks, you get a time in, and because you've got a movement history, so every time you make a move on the client, you sort of store that input and data from that move and the timestamp and whatever. When a correction comes in, you can go back into that movement history and go, okay, where were you at that time? And if it's really simple, like there's no change at all, you'll find out in the next bit. So you basically just take the values away from each other and you compare the difference. And if the difference is, say, 0 or a really, really, really tiny number, it's probably trustworthy. They've probably not done anything dodgy. So you can just sort of ignore it and you can sort of assume the moves they've made since then are correct and continue. If the difference is significant, then something's happened, whether that's they've lagged out and there's been some sort of discrepancy. There is certain situations where if you turn around really quickly in a game, especially my one, and you can power off in a different direction really quickly, the change in velocity sort of screws up if there's a big latency between the client and the server. But besides that, what you then do is you need to do some sort of correction. So you go into this function, and there's loads of different ways to do it. Valve do it a different way. I think Unreal do it another way. There's people are finding their own ways, but the concept's the same. So then you go through this, and you basically find the move that was nearest to the one that you're looking for, right? If it's wrong, you drop that move because it's obviously incorrect. So you replace it with the move that's come in from the server, because you know that that move is the authoritative one, so it's the correct one. What you can then do is, based on that move, you've still got all your inputs that you've made after this correction has been made, because remember, you've got that 80 millisecond gap, right? So you've got 80 milliseconds of inputs, or, I mean, imagine you've lagged out a bit, you've got, I don't know, 200 milliseconds of inputs that have happened. You can't just drop those, because then you'll snap back to this normal position and you would have lost everything you've done since then. So you correct your move, whether that's, there's other ways of doing it as well, where if the move is slightly different, you can interpolate, so you can sort of blend it across, so you can do, I don't know, a tenth of the distance, and you do that enough times over a few frames, you'll gradually get there. If the distance is massive, you need to sort of just snap to that position, which will look a bit jumpy in the player's view, but at least they'll be in the right place. But yeah, so once you've got that corrected move, you just replay from that corrected move all those stored inputs that you had previously in your history or whatever, and you'll get back to this correct, like ultimately correct state, which should match up with the server completely. That's it in theory. In reality, it's not perfect. I've got it working. The issue is I've got something else screwing up with my game, so it's not doing it right. But I mean, it's definitely worth looking at the Valve documentation on this. I've got the title here. It's latency compensating methods in client-server in-game protocol design and optimization. It's pretty long, but I'll put the links up. So there's a Valve documentation, there's Unreal documentation. They're kind of both based off the Quake World version that was years back, and all of these guys that have solved this many years ago, but we just don't know this stuff yet in the web development world. So the other stuff is, aside from networking, which is a pretty chunky topic and worthwhile sort of digging yourself into and learning a bit about, is the stability. And I was saying how when people were cheating the game, they were crashing my server. Well, half of that was my own naivety with not putting error checking into Node and whatever, and basically just letting it crash if something went wrong, because I was more interested in rapidly building up this game because I wanted to learn about WebSockets, which is a good thing about Node. But when it crashes and you're not around, it's not great for testing. So keeping the game running was something that I was interested in, and I needed a way of automatically doing that. So I started using Monet. Has anyone used Monet? Cool, a couple of people. Yeah, it's I didn't know about this before I created the game. It's fantastic. So it's something that runs on your server, and you can script it pretty easily. And the way I have scripted it is I've basically made it look at my WebSockets connection in Node. So it's looking at the port that the WebSockets is meant to go through. This is the script. I mean, it's 4 lines. It's pretty simple. So you just check the website, the domain, which is the local host, because you're running on the same server, you'd hope. And you're just looking, so ignore the 2 lines in the middle. You're just looking for whether the port, say the WebSockets one that I'm using, maybe is port 8000, TCP, whatever. So you're checking whether it's active, right? And that's just the way it does it by default if failed. And it checks in cycles. So you can change the cycle by default is like 120 seconds, so 2 minutes. I've changed it to a minute. In configurations files, it's really simple. But yeah, so if the connection is inactive for 2 times, so that would be 2 minutes in this case, then it thinks, right, the game's probably dead. Someone's probably cheated and crashed it. Let's restart the game. And it just runs through the whole restart procedure and just sort of boots the game back up. So the restart procedure is just running some shell scripts. So here's the shell scripts. It's just, I mean, I don't know too much about it. I just know that that's how it works. I'm more of a JavaScript guy. But it's effectively just a shell script that runs a command line call, which is just booting up Node again, if you run the start command afterwards, and if you run the stop command, it stops the node process that you just run. Pretty straightforward in theory. Really, really useful in context. And it's really not that long, at least anyway. So yeah, I mean, that was it. That was all I needed, and my game was up and running permanently. I've not had to restart it for, I can't even remember the last time I restarted the server myself. So yeah, so as I was saying at the beginning, I used Flash for the audio, which is something I didn't use at the very, very, very beginning of the game, but I couldn't not use it. The reason is because HTML5 audio, as good as it is for, say, music and sound in video, and not sound in video, but sound in general, is not amazing at looping. And the consistency across browsers for looping is just pretty bad. So, for example, I mean, if you're using this for, say, a rocket thruster, say in my game, you've got this short clip that's looping over and over and over and over and over and over and over again, right? So if you've got this inconsistent looping, and what I mean by this is there's like a little gap, a tiny, tiny little gap at the end, which probably isn't noticeable if you're looping, say, a music track, which is like 5 minutes long or whatever. If you're looping a tiny, 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 tiny track, you're going to hear this little sort of gap all the time, and it's just going to not sound right. And that was the problem I had. And there's ways to look around that. Opera actually have a really good implementation of this. It's like super slick. Every other browser, there's slight differences. None are entirely perfect. And there's ways around this, so you can use JavaScript to look for the end event on the audio and push it back to the beginning, because sometimes that might run faster and whatever. But none of it's perfect. You're still going to get a tiny, tiny little gap, and this really, really, really needs to be worked on. Sorry, do you have a question? Right, yeah. So that is another approach. I've seen it in use. I'm yet to see it be perfect. Like, I mean, literally perfect. Which is the problem, because if it's quite a detailed loop, you're going to really notice a tiny, tiny difference. But that is a sort of this guy was just saying it. You get two audio clips, the same audio clip, and you sort of effectively nearly crossfade them right at the end, so they sort of start at the same time when they go through again. So you've always got one loop playing, and the other one sort of passes in over the top just at the end, right? Right. Yeah. Yeah. So that is one of the actual approaches. It's probably one of the better ones actually, but it's not ideal. What I'm getting at is that HTML5 audio, needs to get better. Seth?
Have you looked at Web Audio API or the Audio API Mozilla is coming out? I feel like that solves a lot of the issues of HTML5 audio, especially related to games. So have you taken a look at any thoughts?
So Seth was just saying, have I taken a look at the HTML5 audio API in Firefox, and I think Chrome has got one now, hasn't it? Yeah. How do you mean? So
there's a Web Audio API,
right.
Which solves essentially the low latency problem. Also allows you to do multi-channel audio.
Sure.
And get access to things like the waveform. And I think Mozilla has something. Well, they have an API that has similar intents. Right?
Mm-hmm.
I think the implementation is slightly different, but I think the good news is that there's hope. There's a light at the end of the tunnel, and I think that the new APIs spec'd for the things that games might need are coming very quickly.
Yeah. So yeah, I mean, Seth raises a good point there. There's audio APIs coming out which are giving you much more fine-grained control over the audio, and like giving you access to waveforms, multiple channels. Is that what you're talking about?
Stereo.
Yeah, stereo and stuff. So that's definitely really interesting, and probably something that would be useful in this context. And he also raises another really good point about how, particularly when now gaming is a bit more prevalent, or at least needed, and people are looking into these things, I think the technologies are going to not necessarily be created for them, but at least the kind of performance uses and that kind of stuff is going to be taken into consideration. I hope. I'd really hope. But I mean, things like hardware acceleration in Canvas and stuff, it's stuff that's kind of going to push things a bit further forward than what Canvas was originally intended for. So yeah, I mean, there's no real reason why I didn't use, well, apart from the looping thing. You can use HTML5 audio. It's just, don't feel bad if you want to make a whole HTML5 game and you have to use Flash for the audio. WebSocket.io uses Flash for the WebSockets as a fallback, so there you go. So I mean, there's loads more stuff that I couldn't fit in. It's been quite a long talk, but stuff like canvas optimizations, you can, all sorts of stuff related to that. Using events to decouple your game logic, just simple things. If you use Node JavaScript on the server, you can use your same code on the client and the server if you create it right. Saves you a whole bunch of time. With animations, use request animation frame instead of set timeout, because it puts the animation in control of the browser and it sort of raises the performance. And if you click off your game and go into a different tab, it's not running this timeout in the background and ruining your processor. Things like storage, like looking into things like Redis and MongoDB, these all kind of things that you should be looking into if you want to create these kinds of games. And something really important, control systems as well. Like, we're used to desktop and keyboard and mouse, and that's great. But these technologies work on mobile as well, right? So it's looking into different ways of using JavaScript to control these kinds of games. So like Rawkets, I want to use a control system that Seb Delisle, is a Flash developer who's now sort of doing a lot of cool stuff with JavaScript. He's created one that's based on iOS implementations in games where you got this sort of two thumb joysticks on the screen. And it doesn't matter where you put your thumbs, these two joysticks pop up. And say, for example, your left one's your thruster for your rocket and you can fly around. Your right one is the direction of fire, or velocity of the fire, whatever. It's a really simple control system, and he's created it in JavaScript. I'll put the link up with all the resources for this on my website. So yeah, I mean, the future, like Seb was saying, Seth even, if these technologies, if people start adopting gaming and these high performance sort of uses of these technologies, I think things are going to get a lot better, a lot faster. There's some things in particular that we need, so HTML5 audio being fixed, hardware accelerated canvas, particularly on Mac, it's really bad at the moment. Better documentation for making games in JavaScript. I mean, like this guy at the front, I need to get your name. What was your name? Scott. Like Scott has been saying, this kind of stuff, people have solved these problems before. This is not new stuff. It's just in a new context. So we need documentation specifically related to stuff like JavaScript. And this is something I'm particularly annoyed about. I want to do something about. And there are some websites coming out now sort of helping this in game conferences like, is it New Game? New Game in San Francisco in November, and on GameStart in Poland in September. It's going to help. Just other little things like better ways of benchmarking game performance and stuff. I know Facebook are looking into this. They're not creating games, but they want to look in how to use these technologies better to create games. So I mean, things like some sort of, I don't know, measuring FPS in an interesting way, network performance, and then viewing this in some sort of logical way rather than just seeing it on single players' computer screens, and not just in a log file. So some sort of, I don't know, Google Analytics for game performance, I don't know. Something like that is really needed, I think, to push this forward rather than just experimentation to actually proper game development. So I'm Rob Hawks. That's my Twitter handle, @RobHawks. My blog is rawks.com. This is where I'll put up all the information after this, the slides and stuff. I'll also tweet about it. Unrelated, I did some cool stuff at uni. There's some Twitter sentiment analysis stuff, which was quite interesting, looking into emotion on Twitter and delving into people's souls. So yeah, my job, Mozilla Technical Evangelist. I do a podcast called Explicit Web, which is all about web development. I don't really need to talk about this. Seth mentioned it at the beginning. It's my book. If you're looking into Canvas and stuff, whether you know all about it, that's fine. I mean, if it's something you know someone else is looking into Canvas, might be useful. There are other books out. There's one by O'Reilly, so take a look at those. Something we're working on at Mozilla, which is interesting, is Dev Derby. This is something we're doing every month. This month is HTML5 video, and it's just like a monthly competition just to create some cool stuff with the technologies to sort of see what they can do, have some fun. You can win stuff, Android phones, t-shirts and stuff. So it's useful, like if whether you want to submit something or not, if you know people that are interested in learning technology, students or whatever, it's a good excuse to get them sort of playing with these technologies on a regular basis. Next month will be interesting, sort of touch events on mobile and stuff. So yeah, that's me. Thank you very much. Thanks for having me. And if you have any questions, I'll be happy to take them. Yeah.
What about something like online games? Almost all these clients seem to be able to play video. Why can't you just stream video and audio to the client, stream controls to the server, and move all the protocols you talked about, authority, everything to the server, and just do a video audio stream?
So that was, yeah, so what was your name? Sorry.
It's like Eeyore with an L.
Okay, what, Leo? Okay, Leo. So yeah, Leo was saying there's a technology out at the moment which is allowing you to play games on the internet effectively by streaming down. The game is run on the server, is this correct? And then you stream down audio and video. So you're playing a video stream effectively, and the controls are streamed back to the server, and something changes on the server, it streams back a different image, yeah? So yeah, I mean, this is something that could be looked into, I suppose. I don't quite know if we're ready to do something like that in sort of HTML5 and JavaScript with video streaming HTML5 video and stuff.
One of the issues is WebSockets
Sure.
doesn't send binary data.
Right.
It's kind of a pain, and we don't have UDP, which I imagine these guys are doing.
Mm-hmm.
So we don't have that quite yet either.
I thought HTML5 could play video audio streams.
No, go for it, sir.
Yes, you can play native video, native audio as first-class citizens in the page. But I think the idea is like, how do you get like Gaikai or OnLive to just stream? Right now, WebSockets really only sends message-oriented text data. So you can't actually open an actual stream of actual binary data. So we don't have a really good, efficient way to actually stream binary data from server to client purely with web technology.
I think I'm not sure I understand.
Yeah, I think what we're suggesting is that they would be totally decoupled. The clients would use WebSockets to talk to the server.
As in I had a
server wouldn't talk back with that. It would just send a video stream to be running in my
I have an
widget in the page. Right?
when I click play, my guy shoots forward, and when I click fast forward, my guy turns direction. Does that make sense?
Yeah, I mean, this is an interesting thing that it's been worked on with console gaming, hasn't it? Or PC gaming, at least.
A lot of hardware in that.
Right.
Service for that. They put servers that are close to you.
Yeah.
It's not just the server off of Ethiopia.
Yeah. Yeah, I mean, that's an interesting thing that Scott was sort of mentioning. There's going to be some sort of hardware requirements involved in that. But I mean, it's not impossible. Let's put it that way.
If an event fires, like I shoot somebody and gets the points during the prediction phase, but then I get a message from the server saying that somebody else shot them before I did, then I presumably I would lose the points. Like, how do we handle that?
So yeah, I mean, that's up to your game. But I mean, you've got to add some sort of win logic in there. So whether that's a first come first serve kind of thing, or the question was if you fire a bullet at someone and kill them, but before the message comes back from the server saying that was all okay, it's actually turned out someone else had shot that person before you, do you still get the points, or what happens? So yeah, there's Valve had a problem with this with when players are lagging out. Say some guy might pop out of a wall and shoot someone, and you won't have even seen them, because by the time they pop back in, they would have killed you, but you've not seen them pop out yet, right? And it's a bit screwy. So the way they do it is on the server, they sort of rewind the time back to when that player shot. So it is a first come, first served basis. It might not look correct, but it will be correct based on the logic that the server knows about. So in your case, if I fired and I had, say, an 80 millisecond delay, and it turns out in that 80 milliseconds someone else had already shot before me and killed that person, the server would have done it the correct way. And yeah, okay, your prediction might have been that that player died. Like, you don't predict certain things you might not want to predict, so like the deaths and stuff. You might wait until the server comes in, and there's going to be issues. There's going to be particular delays. There might be. It's better to have a little bit of latency in the deaths and not any in the movement and the shooting, I think. But it's definitely an issue to look into.
It sounded like you were describing like a one-to-one, like tying the simulation updates with the network updates. If you're rendering 60 frames per second, you have to push 60 network updates per second. So you tried like decoupling these loops.
Right. Yeah. So I probably didn't explain that too well. So that is an issue, and that is actually how I did that the first time. Sorry, the question is, the way I described it, I didn't talk about decoupling the network updates and the graphics updates and the physics as well. And this is true, and I didn't do that the first time around. I did learn from that mistake, fortunately, because you're sending way too many updates. So the way I do it now is the physics are decoupled. They're sent actually, the physics and the network updates right now are the same. But on the client side, the physics and the graphics, sorry, the network physics and then the graphics are separate. So physics and networking is running. I have to look into that, but basically I have decoupled it. It is an issue, and it's correct to decouple that kind of stuff because you might want one thing to run at much less in frames per second. But then again, if you're using, it's an important thing to be aware of in the networking side of things because you don't want to send too much data. But if you're using things like request animation frame and stuff, with the graphics side of things, the browser's going to be dealing with, it's going to stop the slowdowns and stuff like that. It's something to be aware of, definitely, and to definitely decouple those updates. Sure? Done? Cool. Thank you. If you've got any other questions, just tweet me or email me. Or I'm actually going to have to shoot off quite soon after this, so you unfortunately won't be able to grab me after, but we'll answer those.